I've got a question.
Yeah, what's up, Ida?
I got the graphing calculator. Is it the TI-84?
Yes, perfect.
Okay.
All right, everyone, good morning. Happy Tuesday. The day is August 8th, 2020. Here is your do now for today. In the chat, go ahead and answer. What's your job? And then out loud, we're going to answer the question, how do you decide whether elimination or substitution is the best method to solve a system of equations? Got a sports agent, a nurse, an astronomer, an engineer, awesome. An oncologist, awesome. A pediatrician, got a lot of doctors. A CRNA, a lot of medical professionals, awesome. A king like the Queen of England. I don't know if the Queen of England is a king, Conrad, but you just want to be royalty, I get it. An anthropologist. My minor in college was anthropology. I loved it, so awesome choice, Noah. A sports broadcaster. For those of you that haven't turned your video on yet, make sure to turn on your video. You have 1.5 minutes to get the question in the chat, your answer to the question in the chat. Nick, you don't know yet. That's cool. You're still young. A psychologist, awesome. An engineer as well. We got 2 engineers in this class. I love to hear that as a math teacher. Thirty more seconds to get your answers up. An NBA player. All right, Christian. All right, let's go ahead and get started. How do you decide whether elimination or substitution is the best method to solve a system of equations? What do you have for me, Conrad?
If both equations don't have a singled out variable, then I will use elimination.
Good.
Like if one of them isn't y equals something x.
Sure. So if one of the variables isn't isolated, then you want to use elimination. If a variable is isolated, then you want to use substitution. Good. Any questions for Conrad about how to decide? All right, let's go ahead and do our good things for today then. Today's good things are going to come from Noah, Tyler, and Anam. So let's start with Noah. Noah, what's your good thing?
My good thing is that, oh gosh, I slept pretty well.
Great, awesome. That's great. Thanks for sharing. Who did I say next? Tyler, what's your good thing?
I don't really have one, but I guess I spent more time with my family this weekend.
That's awesome. That's great. I love family time. Thanks for sharing. And then, Anam, what's your good thing?
I saw some of my cousins yesterday.
Yay, awesome. Another family tag. Great. Thanks for sharing. My good thing was I really enjoyed getting to virtually meet some of your parents yesterday during back to school night. I always enjoy getting to see your parents and meet them because we don't really get an opportunity to do that throughout the school year. So that was my good thing. Couple announcements before we get started. Your Big Ideas Math 1.3 Part 3 assignment is due this Thursday. Just to make sure that you don't get your questions unnecessarily wrong, take a note of all of these rounding instructions. So for 17A, you want to round to the nearest hundredth. 17B, round to the nearest $100. And then 18, round to the nearest tenth. You want to take a screenshot of this, go for it. If you want to write it down, go for it. If you want to take a picture of it, go for it. Either way, make sure that you copy that information down so that you can get those questions correct, because if you don't round it correctly, it will tell you your answer is wrong. And I'd hate for you to get fewer points even if you, just because you had a rounding error. So make sure to write that down. Graphing calculator rentals are today. So they've started already and they go till p.m. today, and then it's also from 9 a.m. to 6 p.m. tomorrow. Before you come to get your graphing calculator, you need to sign up online. So you need to fill out the online form and print out the permission slip to have your parents sign it. We do have extra permission slips here, but you will need your parent to come with you so that they can sign it, and it's $20 per. Just as a reminder, we do need calculators tomorrow. So for our lesson tomorrow, we will be using calculators. So make sure that you have it ready with you by tomorrow. And then you'll also need it for that 1.3 Part 3 assignment, which is due on Thursday. Any questions about the announcements? All right, like I said yesterday, I wasn't here, but there was an assignment on Canvas, which was to upload your completed substitution and elimination worksheet. Are there any questions about that I can answer?
I didn't understand it. It was confusing.
Which problem specifically, Ida?
Let me check. Hold on.
Okay. Any other?
I didn't get number 3 for the substitution.
Okay, let's go to number 3. Let me share my screen with you. All right, so let's see what the problem was, because I don't remember it off the top of my head. All right, so it's 5x plus y is equal to -2, and then 3x plus 5y is equal to 34. Okay. So for substitution, it asks you to solve by substitution. You need to isolate for one of your variables. So I would say the easiest one to isolate is this y right here, because it's all by itself and it has no coefficient. So to isolate for y, you need to get rid of this 5x. So we're going to subtract both sides by 5x. So you'll get y is equal to -2 minus 5x. Good so far? All right, from here, you're going to take this -2 minus 5x and you're going to plug it in for y in the second equation. So it's going to be 3x plus 5 parentheses -2 minus 5x is equal to 34. Did you get this far, Ida?
Yeah.
Okay, so then you distributed the 5. So you'll get 3x minus 10. And then 5 times -5x is -25x is equal to 34. 3x minus 5x, combine those like terms. So 3x minus 25x is -22x minus 10 is equal to 34. Add 10 to both sides, so negative 22x is equal to 44. And then divide both sides by negative 22. So x is equal to 44 divided by negative 22, which is negative 2. Were you able to get that far?
No.
Okay, does that make sense how we got there?
Yeah, kind of.
Kind of, do you need me to stop and go over a part before I move on?
No.
Okay, cool. After that, after you get your x, you're going to plug it into either one of the equations. I'm going to go ahead and plug it into the first one. So it's 5 times negative 2 plus y equals negative 2. 5 times negative 2 is negative 10 plus y is equal to negative 2. And then I'm going to add 10 to both sides. So y is equal to negative 2 plus 10, which is positive 8. Does that make sense, Ida?
Yeah.
Cool. Any other questions from that worksheet?
No, but I have one for the actual the assignment on big ideas math that I did not get.
I'm going to hold off on that because are you referring to one where it was 3 variables and 3 equations?
You said what?
Are you referring to the
It was
problem,
number 3.
the 3 variables
Tuition.
equations? Like
I think so.
it had an X, Y, and Z. I'm going to hold off on that because we haven't talked about those notes yet. So I actually assigned that earlier. It was supposed to be assigned today, and we haven't gone over that. And I thought I deleted it and reassigned it today, but I couldn't due to technical error. So hold off on your question, and then we'll do the notes for today. And then if you still have that question, then I'll answer it at the end. Does that work?
Can you do number 6?
Number 6 from the worksheet?
Yeah.
Okay, yes, from yesterday's worksheet. All right, let's go back and see. Where is number 6? Let me just check the time real quick so that I know that we have enough time to do today's notes. All right, just because today's notes are going to take a little bit extra time, I'm going to hold off on number 6. I made a note, but I'm going to pause 5 minutes before the end of class, and we'll do number 6 as well. All right? Just want to make sure that we have enough time to get today's notes done. Okay, so for today, we're going to take this up a level. So on Friday and yesterday, we talked about 2 variables and 2 equations. So that's a 2 by 2 system of equations, 2 variables, 2 equations. Now we're going to up the difficulty level a little bit, and we're going to do 3 by 3 systems, which means you're going to have 3 equations and 3 variables. We still use the same method, so you still use elimination and you still use substitution, but it's going to be a couple extra steps because now you have to solve for 3 variables, an x, y, and a z, as well. Yeah, you have to solve for 3 variables, and you have 3 equations. So the first method we're going to go over is elimination. So the steps to solve for elimination is you want to pair 2 equations together to eliminate 1 variable. Then you're going to write a new system with 2 variables and solve. Then you're going to substitute into one of the original equations and solve for the remaining variables. And your answer should always be in an ordered pair, x, comma, y, comma, z. So I know that sounds like a lot. It makes a little bit more sense once we start with an example. Are there any questions before we go on? All right, first example. So first you want to pair 2 equations to eliminate 1 variable. It doesn't matter which equations you pair together. I usually do the first 2. So I'm going to do 2x minus y plus z equals 4. And then I'm going to do the second equation as well. X plus 3y minus z equals 14. Not 14, sorry, 11. I was looking at the wrong one. Okay, from here, I'm going to decide which variable I want to eliminate. So I'm going to choose the x, the y, or the z. I'm going to call on someone to help me out. Which variable makes the most sense to eliminate given these two equations? Which variable makes the most sense to eliminate given these two equations? Henry, you want to try it?
Z,
Z, and why do you say Z?
because there's no number on it. It's just the variable, and it's minus Z minus Z, so it's just the easiest. I don't know.
You're absolutely right. I agree with you. You should choose Z because they have the same coefficient, which is 1, and then you have one positive and one negative. So you don't actually have to multiply the equations at all to eliminate Z. You can just go ahead and add those two equations together, and that will take care of it for you. So you've got 2x plus x, which is 3x. Negative y plus 3y is positive 2y. Z minus Z, those cancel out. And then 4 plus 11 gives you 15. 4 plus 11 gives you 15. Any questions on how we got that? Okay, I'm just going to circle this because I know I'm going to have to come back to it eventually. Not right now, but I have to come back to it eventually. All right, so we got the first two. Now I'm going to pair number 2. So x plus 3y minus z equals 11. And the last equation, 4x plus 3y minus z equals 14. So we're going to put those two together. All right, so because we chose to eliminate z the first time around, we have to eliminate z the second time. We don't get a choice. We can't be like, oh, actually it might be easier to eliminate y's. That won't work. If you chose whatever you chose the first time, you have to make sure you choose the second time. So we have no choice. We have to eliminate the z's. To eliminate the z's, you want to make sure that they have the same coefficient and opposite sign. So if I look at these z's, they have the same coefficient, but one's negative, or they're both negative. So I want them to be the opposite sign. So in order to do that, I'm going to multiply the bottom by -1. Anytime you multiply an equation by -1, you're going to change the sign. So I'm going to copy down the first equation because I didn't end up multiplying it by anything. And that second equation, I'm going to multiply by -1. So it's going to be -4x minus 3y plus z equals -14.
Wait, why'd you put a -1?
Because when you eliminate, you want to make sure that your z's have opposite signs. Right now, they're both negative, so that's not going to work. You want one negative and one positive. So the way you can change the sign is just by multiplying everything by -1. So now my negative z changed to a positive z, which is what I want. Then you've got x minus 4x, which is -3x. 3y minus 3y, that cancels out, which is a coincidence. Normally that doesn't happen, but it works out in our favor. We weren't trying to eliminate the y's, but they happen to cancel out. Negative z plus z, that cancels out as well. And then 11 minus 14 is -3. So like I said, this is a unique problem. Normally you don't cancel out two variables. It actually works out in our favor that it worked out that way, but that doesn't always happen.
My question is, how do you know when you're supposed to add and subtract it?
You always add the two equations together. You always add the two equations together. So x plus -4x is the same as saying x minus 4x. 3y plus -3y is the same as saying 3 minus 3y. Negative z plus z, and then 11 minus 14. The reason I like to add them is because then you can just look down and follow the signs. You don't have to worry about anything. Does that make sense?
Yes.
After that, you're going to divide by -3. So x is equal to -3 divided by -3, which is 1. X is equal to 1. So like I said, normally that doesn't happen. We have to usually do step number 2, where we write a new system with two variables. But in this case, because the y and z got eliminated, we already know what our x is. Once you know what your x's, or once you get one variable solved for it, you're going to have to plug it into one of the equations. Do not plug it into one of the original three because that has too many variables. So it won't give you any, it won't be any help if you try to plug in the one to one of these three equations because you have three variables. So you want to plug it into an equation that only has two variables. So that would be this guy right here, the 3x plus 2y equals 15, which is why I circled it, because we have to come back to it. Plug this 1 back in over here. So it's 3 times 1 plus 2y equals 15. 3 times 1 is 3 plus 2y equals 15. Subtract 3 from both sides, so 2y equals 12. And then divide both by 2, so y is equal to 6. Oh, you can't see that. Sorry about that. So plug in the 1 and then solve for y. Are there any questions about how we got the y? All right, now we've got two variables. We've got the x, we've got the y, we still need the z. So once you have two variables down, you can go back to one of these original three equations and choose one to plug the x and the y back into. It doesn't matter which one you choose. I'm gonna go with the first one, so 2x minus y plus z equals 4. Like I said, it doesn't matter which one you choose. But now I'm going to plug in the 1 for x, and I'm going to plug in the 6 for y. So it's going to be 2 parentheses 1 minus 6 plus z equals 4. 2 times 1 is 2 minus 6 plus z equals 4. 2 minus 6 is negative 4. And then we're going to add 4 to both sides. So z is equal to 8. Any questions about how we got z? Your final step is you want to write it as an ordered pair. So we organize it as your x value, your y value, and then your z value. So 1, 6, 8, 1, 6, 8. Any questions about that before we get on to our next example? All right, when you're finished, go ahead and flip the page and we'll go on to the next elimination example. All right, this one's going to be a little bit more traditional, so we won't get that exciting part where we got to eliminate two variables. So the first step, we're going to do x plus y plus 2z equals 3, 2x plus y plus 3z equals 7, negative x minus 2y plus z equals 10. Pair two of those equations together. So I'm going to start with the, and try to copy this down correctly. So I start with the first two. All right, I'm going to go ahead and call on someone for this next question. What variable makes the most sense to eliminate first? So if out of these two equations, which variable should I try to eliminate? What do you think, Clervins?
Why?
Why? I agree with you. Why do you say why?
Because it has no numbers next to it.
Yeah, not necessarily that it has no numbers next to it, but it has the same coefficient. Essentially, the coefficient is 1. But remember, in order to eliminate, I need to have a positive and a negative. So how can I change one of those equations to have a negative y? How can I change one of those equations to have a negative y? What do you think, Jonathan?
Multiply the bottom one by -1.
Good, yeah. So I'm going to multiply this bottom one by -1 because that's going to give me the opposite sign. So I've got x plus y plus 2z equals 3. And then this positive 2x is going to become a negative 2x, negative y minus 3z equals negative 7. Now we're going to add those equations together. So you just go down, x minus 2x, that's negative x. Y minus y, that cancels out, which is what we wanted. And then 2z minus 3z is negative z. 3 minus 7 is negative 4. So that's one of your eliminated equations. Any
I
questions?
got a question.
Yes.
Okay, so when we're like, you know how for the x plus y plus 2z equals 3, and then the 2x plus y plus 3z equals 7, like how do you know to pick which like variable
Great
to
question.
eliminate?
You always want to choose a variable that has the same coefficient. So you don't want to choose the x's because this is a 1x and this is a 2x, so they don't have the same coefficient. You don't want to choose the z's because you have a 2z and a 3z. They don't have the same coefficient. So y makes the most sense because it's 1y and 1y. Does that make sense?
Yeah, I get it. And then also, like, you know how you said there's supposed to be like one negative?
Mm-hmm.
Can we just like always multiply?
Yeah,
That
you can
happens?
always change it to a negative. You can always change signs by multiplying by a negative 1.
Okay.
Any other questions? Okay, so now that we did the first two, we have to do the second two. So we're going to copy down 2x plus y plus 3z equals 7, and negative x minus 2y plus z equals 10. Because we chose to eliminate y the first time around, we have to eliminate y the second time around. So you can't look at it and be like, actually, I want to eliminate the x's because it looks easier. That won't work. You have to choose the y's to eliminate now. So that makes this a little bit tricky because now we'll notice that we have different coefficients. We have a 1y and we have a negative 2y. So my question is, what can I multiply this first equation by so that the coefficient will match this 2? What can I multiply the first equation by so that the coefficients match? What do you think, Christian?
You can multiply by -2.
I would just multiply by positive 2 because you already have a positive and negative for the y, so you don't have to worry about changing the sign. Does that make sense?
Yeah.
All right, so if we multiply the first equation by 2, 2 times 2x gives us 4x. 2 times y gives us 2y. 2 times 3z gives us 6z. And then 2 times 7 gives us 14. And then on the bottom, we're just going to copy down negative x minus 2y plus z equals 10. All right, from here, we can go ahead and add our equations together. So 4x minus x gives us 3x. 2y minus 2y, that cancels out, which is what we wanted. 6z plus z gives us 7z. And then 14 plus 10 gives us 24. My bad. So that's your second equation. So this is what I was saying. This is most likely what's going to happen. You're not going to get lucky enough to eliminate 2 variables every time. Most likely you're going to get 2 equations now, but you did eliminate the y's. So now we're down to just 2 equations, 2 unknowns, which is what we did on Friday. So that's your goal. You're trying to go from 3 equations, 3 variables, down to just 2 equations, 2 variables. So this is where the fun part comes in. We get to do elimination again. But now we just do it with 2 variables. So I'm going to copy down the equations that we circled. So we've got negative x minus z equals negative 4. And then we've got 3x plus 7z equals 24. All right, let's choose a variable to eliminate. I'm going to go ahead and call on someone. Which variable do we want to eliminate? Which variable do we want to eliminate? What do you think? Bo.
Yes.
What variable do you want to eliminate? The x's or the z's?
X.
Okay, cool. And why do you choose x?
I don't know.
You don't know? I mean, I don't disagree with you. I choose x too. It doesn't really matter in this case because the x's don't have the same coefficient and the z's don't have the same coefficient. So either way, there's no better choice. So I would go with the x's as well. Great. Okay, so because I don't have a coefficient that matches, I need to fix one of the equations so that it has the same coefficient. So if we're trying to eliminate the x's, like Bo said, what do I need to multiply by to get the same coefficient? What do I need to multiply by to get the same coefficient? What do you think, Lexi?
If you multiply the top equation by 3.
Yep, good job. So if we multiply the top equation by 3, we're going to get a negative 3x, which is what we want. So 3 times negative x gives you negative 3x. 3 times negative z gives you negative 3z. 3 times negative 4 gives you negative 12. And then we've got 3x plus 7z equals 24. And now we can add those together. Negative 3x plus 3x cancels out. Negative 3z plus 7z, that's going to give us positive 4z. Negative 12 plus 24 gives us positive 12. And then we're going to divide both sides by 4. So z is equal to 12 divided by 4, which is 3. That's one variable, but we still have to solve for the other two. So when you're trying to solve for the other two, do not try to plug in the z equals 3 into one of the first 3 equations. That's not going to work because you're going to end up with more variables. What you want to do is choose one of these 2 equations that only have 2 variables to solve for z. So I'm going to go ahead and plug it into this first one, negative x minus z equals negative 4. So we've got negative x minus z, but instead of z, I'm going to plug in negative 3 is equal to negative 4. We're going to add 3 to both sides. So negative x is equal to negative 1. And then we're going to divide both sides by negative 1. So x is equal to positive 1. Any questions about how we got our x value? Okay, we still need 3 solutions. We need an x, y, and z. So how can I solve for y? That's the one I'm missing. How can I solve for y? What do you think, Noah?
I use one of the first 3 now that I have 2 variables.
Yeah, so which one do you want to plug it into?
The first one.
Sure, let's plug it into the first one. So now that you have 2 variables, you're going to plug it into one of the original 3. So Noah says we should plug it into x plus y plus 2z equals 3. That's fine. You can choose any of the ones you want. So x is 1 plus y. We don't know what y is, so that's your variable. Plus 2 times 3 is equal to 3. And then 2 times 3 is 6 equal to 3. Combine your like terms, so 1 plus 6 is 7, so we've got 7 plus y is equal to 3, and then subtract 7 from both sides. I'm going to go over here so I have a little bit more room. So y is equal to negative 4. So you've got your 3 solutions. You've got 1, -4, 3. Don't forget to write it in an ordered pair. So x first, then y, then 3. Questions?
I have a question. So you know how the y was canceled out in the beginning?
Mm-hmm.
So if like one of the variables gets canceled out, can we just like put it into the one of the first 3 old equations?
Yeah, so you're gonna have to put it into once you get 2 variables solved for, so we had z and x solved for, then you're gonna have to plug it into one of the first equations, because you're right, the other 2 didn't have a y in them anymore. Any other questions? Okay, let's see if we can get example 3 done, because I do want to show you one substitution before you leave. I think we can do it. Are there any questions before we move on to the last example? I know it's a lot of stuff today. I apologize. It won't always be like this. Okay, let's go to the last one that we'll do for today, which is example 3, solving systems by substitution. So just like with 2 by 2s, you want to use substitution if you can easily isolate for a variable. So you want to use elimination if they're all lined up. You want to use substitution if one of the variables is isolated. So you want to choose an equation with only 2 variables if possible, and then eliminate one of the variables. Not eliminate, excuse me, solve for one of the variables. Then you want to substitute the variable into the other 2 equations. Then you're going to write a new system with 2 variables and solve. And then you're going to substitute the variables into one of the original equations. Oops, that was a typo, classic. And solve for the remaining 1 variable. A lot of words, makes a little bit more sense when we use it with an example. So the first step is you want to look for one of the equations that only has 2 variables. So we're automatically going to focus on equation 2 and 3, because these are the only ones that have 2 variables. Then you're going to ask yourself, okay, which one of these equations is easier to isolate for a variable? Would it be easier to isolate x plus 5y equals 9, or would it be easier to isolate 4z minus 5x equals 4? You always want to look for a variable that doesn't have a coefficient. So that x is all by its lonesome, there's no number attached to it. That's the perfect one that you want to isolate for. You can do it for any of the other guys, but it's just going to make your life more difficult, and you're going to end up having fractions. And I know how you all feel about fractions. It's not fun. So choose a variable that's all by itself. It'll make your life 10 times easier. So we're going to try to isolate for x so that it's all by itself on one side of the equation. How can I isolate the x? How can I isolate the x? What do you think, Elise?
By getting x by itself.
Yeah, how am I going to get x by itself? What do I need to get rid of?
Subtract 5y on each side.
Yeah, yep. Subtract 5y. So you're left with x is equal to 9 minus 5y. Great, step 1 done. Step 2, what you're going to do is you're going to take this 9 minus 5y and you're going to plug it in for x in the first equation, and you're going to plug it in for x in the second equation. So let's do the first equation first. So we're going to do 2x, but instead of x, I'm going to plug in a 9 minus 5y plus 3y minus 2z equals -1. And what I want to try to do when I simplify this is I want to get all of my variables on one side and I want to get all of the numbers on the other side. So first up, I'm going to distribute this 2. Are there any questions before I go on about how we substituted this 9 minus 5y into x? All right, so we've got 2 times 9 is 18. 2 times -5y is -10y plus 3y minus 2z equals -1. Combine your like terms, so -10y plus 3y, that gives us -7y, minus 2z is equal to -1. And like I said, your goal is to get all the variables on one side and all the numbers on the other side. So what you want to do is get this 18 over to the other side. So we're going to subtract 18 from both sides. So we'll get negative 7y minus 2z is equal to negative 1 minus 18 is negative 19. I'm going to circle that because that's going to be one of the equations that I'm going to eventually use. So I want to remind myself that that's important. I'm going to come back to that. Are there any questions so far? Okay, like I said, there's a lot of steps in this, so that's the hardest part, is keeping track of all the steps. Now that we substituted it in for the first equation, we still have to substitute it in for the second equation. So we still have to do 4z minus 5, but instead of the x, I'm going to plug in 9 minus 5y and have that equal 4. So this time I'm going to distribute the negative 5, so it's going to be 4z minus 5 times 9 is 45. Negative 5 times negative 5y is positive 25y is equal to 4. I'm going to get all the variables on one side, all the numbers on the other side. So I'm going to add 45 to both sides. So we'll get 4z plus 25y is equal to 49. Your last step, I just want it to match the order of this equation right here. So I want the y to come first and then the z. So I'm just going to switch these around. So it's 25y plus 4z is equal to 49. And that's my second equation. Woo, okay. We are getting into it. All right, now that you've got your two equations set up, we have to write a separate system. So we went from a 3 by 3 down to a 2 by 2. Now we only have two equations and two variables. Because these are already lined up, because you already have the y's and the z's and the numbers, the method that makes the most sense to solve would be using elimination. So I'm going to just copy down these two equations. Over here. And my first question that I'm going to ask you all is, which variable should I eliminate? Which variable makes more sense to eliminate, the y's or the z's? Which variable makes more sense to eliminate, the y's or the z's? What do you think, Nick?
The y.
Why do you say the y?
I don't know.
You don't know? Any volunteers? Which one would make more sense to eliminate?
The z.
Elise, you say the z, and Natalie, you also said the z. Natalie, why do you say z?
Because you just multiply the first equation by 2, and that's equal to negative 4z.
Exactly. So the reason, Nick, why you want to choose z and not y, because for the y's, it's much harder to find a number that both 7 and 25 go into. Whereas for the z's, all you have to do is multiply that first equation by 2, and then you'll get a negative 4. So it's much easier for the z's to match up coefficient-wise because they both 2 and 4 go into 4. Whereas for the y's, you have to multiply both equations to try to find a number that both 25 and 7 go into. Does that make sense? Why we choose z instead of y, or yeah, z instead of y. Okay, I'm gonna go ahead and multiply this out and then we'll pause right there because we're leaving at 10:05. So 2 times negative 7y, that gives us negative 14y. 2 times negative 2z gives us negative 4z. And 2 times negative 18 gives us negative 38. And then we're just gonna copy down the bottom one as is because we don't need to multiply it by anything. All right, we're gonna go ahead and finish this up tomorrow. You should have enough time to start the assignment. It won't be due until tomorrow at 11:59. So I would suggest starting it today. You can definitely do the elimination problems. There's only like 5 problems on this because it does take a long time. And then I can answer any questions. I apologize, I did not get to number 6 of last night's homework, but I will make a point to do that tomorrow in class as well. It just ended up taking a little bit longer today. Tomorrow we are going to start with the calculators as well. So there will be 2 things you need to download. You'll need to download the notes and you'll need to download the calculator instructions in order to prepare for tomorrow. Here are your assignments for today. Again, 1.4 part 1 will be due Wednesday, so tomorrow at 11:59. And then 1.3 part 3, that's from last week, that's going to be due Thursday. I'll stick around if you have any questions, but if not, feel free to log off. I'll see you tomorrow.
I have a question. It was about the big ideas math that you said you're gonna answer later.
Yes.
This wasn't about this. It was actually about like the linear regression when you plug the numbers in the calculator. And I kept plugging it in, and like the slope I got was like a negative. So like it just didn't add up. Numbers I got didn't match my computer. Didn't match on my computer. Number 3 for the modeling with linear functions. Exercise was 1.3, and it was number 3.
Okay.
It was like the tuition in college.
Exercise 3.
Mm-hmm.
I don't think that was part 1 or part 2.
It was part 3.
Part 3. I don't think I assigned that.
Chapter 1, modeling linear functions. Section exercises 1.3.
Because I think I have problems 14, 16, 17, 18 on that.
I don't know, you can't see it.
What's it about?
It's like it's kind of what we did with the calculators, where we plug the graphs in.
Yeah, just read. What's the table of values saying, or just read me the problem.
All right. The data pairs X and Y represent the average annual tuition Y in dollars for public colleges.
Okay, cool. So you're saying that your calculator kept giving you a negative slope?
Yes. And the slope didn't, in the y-intercept, it didn't match what's on here.
So if you go to your table of values in your L1 and L2, do you remember how to do that?
You go to stat, you go edit.
Mm-hmm. And so for L1, did you plug in 0, 1, 2, 3, 4, and 5?
Yes.
And then for L2, you plugged in 11,386.
Wait, 11,000. Oh, I see what I did wrong. I thought 11 was like its own thing. It's the okay, I got you. Thank you.
Yeah, no problem.
Good thing.
I have a question.
Yeah, what's up, Ida?
So, I don't know if you remember yesterday. Remember when I texted you on Canvas?
Yeah, so we're on for Thursday.
Yeah, for Thursday afternoon, like, what do I do? Like, get on a Zoom or something?
Yeah, so if you go online to my Canvas homepage, do you see how at the bottom it says office hours? And there's a link?
Yeah.
Just follow that link.
Yeah. Okay. And do you remember how last week, like, we had those assignments that we had to do with the graphing calculator?
Yeah, that's not going to be due till Thursday though.
Yeah, I just got the graphing calculator like this week, so I didn't really kind of understand the assignment. So like, could you help me on Thursday?
Yeah, so there's only like 5 problems that we have to do, so we can work on that on Thursday during office hours.
Okay, and can I turn in the paper, the one that was due from yesterday, tomorrow?
Yeah.
Because I'm still working.
That's fine. Just send me an email once you turn it in, so I can go back and give you the credit for that.
Okay, thank you.
You're welcome. Anything else?
Mm-mm.
Okay, cool. I'll see you tomorrow then.
All right.